Okay, so today we're going to look at the absolute value function. So a function of the form f of x equals a times the absolute value of x plus b plus c, where a cannot equal 0 is an absolute value function. So we're going to start off with just looking at what the parent function is. So f of x equals the absolute value of x. So we have our domain values, -3 through +3. And remember, domain value represents our x's. So I'm going to go ahead and just fill these in to our table. And now we want to find our y values. So if we plug in -3, the absolute value of -3 is a +3. So if we wanted to write out our ordered pairs, we would have -3, 3. The absolute value of -2 is a +2. So -2, 2. The absolute value of -1 is 1. So we have the ordered pair -1, 1. The absolute value of 0 is 0. So 0, 0. The absolute value of 1 is 1. So the ordered pair is 1, 1. The absolute value of 2 is 2. So the ordered pair 2, 2. And then the absolute value of 3 is 3. So we have the ordered pair 3, 3. All right, so if we graph this, plot our points, we have -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And then we can connect our points to make our graph, which happens to be V-shaped. So anytime we graph an absolute value function, it will have this shape. And then we're going to talk about the different ways in which we move it throughout the next couple sections. So now let's talk about the different parts of the graph. So first we have in behavior, which means we're going to look at what are the arrows doing. So our arrows are both pointing up. So I'm just going to draw 2 up arrows. Our domain, since we have an arrow on the left and an arrow on the right, that means we're going from -infinity to +infinity. So our range, we need to figure out what is our bottommost y value. So our bottommost y value is the line y equals 0. And then we have arrows, which means that we're going to be continuing to go up to +infinity. So our range is from 0 to infinity. All right, so a new vocab, axis of symmetry, that's the line that cuts your graph in half. So here would be the y-axis. So that x value is 0. So our axis of symmetry is 0. Okay. Now we have the vertex. And the vertex is that bottom or topmost point of the graph. And that ordered pair is 0, 0. And now we want to look, where is our graph crossing the x-axis? And it's crossing the x-axis at 0, 0. And where is it crossing our y-axis? And that also is 0, 0. All right, so now we want to start looking at what happens when you change the value of the coefficient in front of the absolute value, or the a value. So let's look at this first one. F of x equals 2 times the absolute value of x. So let's use the x values, -2, -1, 0, 1, and 2. So if we plug this in, we have 2 times the absolute value of -2. The absolute value of -2 is +2, and 2 times 2 is 4. So our ordered pair is -2, 4. 2 times the absolute value of -1. The absolute value of -1 is 1, and 2 times 1 is 2. So we have the ordered pair -1, 2. 2 times the absolute value of 0 is 2 times 0, which is 0, or the ordered pair 0, 0. 2 times the absolute value of 1 is 2 times 1, which is 2. So we have the ordered pair 1, 2. And then 2 times the absolute value of 2 is 2 times 2, which is 4. So we have the ordered pair 2, 4. All right, so if we graph this, we have -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4. I'm going to go ahead and connect our points to make our V-shaped graph. And I'm going to try to get both of these in together. Okay, so look at what happened to our graph. Okay, it got a little bit taller. So this is called a stretch. It's a vertical stretch of 2. Okay. Something that we can look at, if we start at our vertex 0, 0, how do we get to this point here? Well, we would go up 2 to the right 1. So our A value equals the slope to the right. And then we use our axis of symmetry to reflect to get the other side of our B. All right, so let's go ahead and fill out the rest of this little bit. So we're in behavior, we're still facing up. So we're gonna have 2 up arrows. Our domain of an absolute value function is always -infinity to positive infinity. The range, our vertex is still on the x-axis, so 0 to infinity. Our axis is symmetry, so the line that cuts the graph in half is x equals 0 still. The vertex is still on the origin, which means our x-intercepts are still at the origin, as well as our y-intercept. All right, so knowing that, I want you to go ahead and try B, f of x equals 1/4 times the absolute value of x. You can either use the idea of the slope, or you can fill in the table. I'm going to help you out. If you do the table, let's use the points. Let's see here. Let's use -4, -2, 0, 2, and 4. So try that. And then also I want you to try C, where we have a negative value, and see if you can figure out what happens. So for this one, let's use -2, -1, 0, 1, and 2. And we'll talk about what we get and what we can conclude in class.